obviously a mine. Not so obviously, and you can probably see where I'm going here. What is reclamation? What does that mean?
Reclaiming the land.
What does that mean?
Back to its natural habitat.
Bringing it back into goodness or its natural state or something. They were just in different stages of reclamation. One of them was still open, one was processing, one was filled, and one is revegetating. I'm sure you all understand that as a business thing, it's a really crappy problem for somebody who runs a mine. This is one of the worst economic obstacles for the mining industry, that you don't know how well it's going to go. You might make a little profit, and then you got to spend it all plus some to reclaim. You might make no profit, and all of a sudden you got to lose even more money on the reclamation. You might make some profit, but then you got to give it all away to the, planting vegetables and stuff. Hopefully we assume that the miners do well and they get their returns, and then they've got enough money that it's a reasonable tax to make them reclaim the property. But I hope that it goes without saying that this is a big fly in the ointment for a miner. There's, of course, that same debate, like we talked about in restoration. What's good enough? Like, check it out. Okay, sure, it's reclaimed. I filled in the hole. It's not a giant rain funnel to pollute groundwater. Is that good enough? Like, no baby's going to fall and die in there. That's pretty good, right? And if you're talking to like a geologist, most miners have a geology background. Ecosystems are just like skin cells. They come and go because they're thinking on a much bigger time frame and a much bigger scale. A lot of miners just don't see the point in hassling with these ecosystems that are relatively trivial compared to the geology that they're usually thinking about. Or like, hey, is that good enough? I put some sand on it. Like, now seeds will grow. Or like, hey, if you just can't see it, if you just can't tell where the mine was, if I just hide it, then you can keep your beautiful wine country. Is that good enough? Or like, should we make a park out of it? Anybody know where this is? Nope.
LA.
Nope.
Japan.
Nope. Yes? Say yes? No?
Isn't that Los Positas and Henry's in LA?
That's right. Local pride. There's my house. So we walk up the street, past my homie Dave's house, go up the hill, kick it on the wedding lawn. Every now and then I'll do some barbecues down at like the wedding grill. Sometimes we take the walk down the road, and my children go play in the playground, which is right on top of what used to previously be a
oil mine.
Landfill. That road, Valerio, used to go through a gate. The trucks would pull in, they would drop their garbage, the garbage would get pushed around and then buried in the landfill. They would take dirt off the front side and make the layers of landfill. There's intact habitat here along the ridgeline, but a lot of it has either been bulldozed and filled with garbage or is currently an artificial lid on top of the garbage. Yeah?
Think you done like 10 foot down that's going to be up there.
Don't quote me on the 10, but yeah. Yeah.
What's like the toxicity radius? Like how far does it stretch before it's actually okay?
Depends what you're measuring and what you mean by okay. You can probably detect the landfill for a great distance. But like, my kids go play in that grass and I'm not worried about it, so it's not like that toxic. But like the water that percolates through there is some of the most polluted groundwater in the county.
What about like an open mine right now?
Worse. I mean, I don't know, like specifically these aren't, none of us is talking about numbers. You said how toxic. So, you know.
No, like what's the radius? Like how far does it expand? What's the distance before it's
Most of what you would consider a toxin doesn't travel very far. I don't think you could sense its presence more than a few hundred yards in almost any manner. Yeah.
So does
Except downhill, because of the water. Sorry.
so does that like percolate into the runoff at the pit?
That's one of the. So the pit is biologically polluted by urban runoff, but chemically polluted primarily by what used to be a landfill there. Basically.
Top 10 in the state, right?
Oh yeah. It's one of the only places that has reliably unhealthy water quality on the entire California coast. Like there's very few places that have such reliably bad water. Do you surf there like daily?
Yeah, a lot.
Yeah. So yeah, there used to be a landfill. And story is, it was an open air dump back before there were laws about how to manage your dumps. So it was like it was one of the more scuzzy landfills. It wasn't technically a landfill, but the word back then was dump. Because the stuff was just open air, like a pile on top of dirt. That's it again. And having a tour of the campus. Thank you.
Don't worry, it's every car.
It's going to sound like it's personal. Like, I don't mind. Like, if he just didn't come to class, like great. Like, Kupiak, go get it, girl. Whatever he's doing, it sounds awesome. But the whole thing, like, oh, I'm absent, but I'm really not. I got you. It's like, what you got? Like, all right. Yeah.
When you say, you're talking about landfills, not mines, right?
So both landfills and mines are considered ways in which we interact with this thing. And so this unit will do both. I introduce reclamation, mining, and garbage in the same intro slideshow because that's where we're going in this unit. We've got one chapter on the geology and the mining and one chapter on the trash and the waste disposal. And before we do any of that, I got to make sure that you know some fundamentals. These are, you know how I do this in every unit, like the basics, to make sure that we're all starting with the same understanding. So that is your planet.
Do you know how much the Earth weighs?
Your mom plus 5 pounds. Okay. One thing that I hope you'll notice here, the scale is pretty close to accurate. It's off on the thickness of the atmosphere. The atmosphere is technically thinner than it looks. And it's off about the relative layers of the core. But roughly, like orders of magnitude, that's about the right thickness for the crust relative to all the other stuff, which is liquid. So we've got the atmosphere, the crust, the upper mantle, lower mantle, outer core, and inner core. If you don't know those terms, you've got to write them down because those are going to come up a lot. The inner core is technically solid. It's got so much pressure that it can't be a liquid. It's been pushed into solid form. even though it's extremely hot, it's like 4,000 degrees Celsius or something. Like,
How does it, I mean, it's like keep its heat?
it doesn't keep heat, it is subjected to heating because of all this stuff piled on top. All the planets are really hot on the inside because there's this thing called gravity, which is holding the planet together. And when you've got more and more and more stuff piling on top of your head, that makes more and more pressure, and pressure equals heat. The heat source is basically the weight of everything above it. So as long as there's stuff above it, it keeps its heat, so to speak. Yeah?
Does any of that like inner heat make it to the surface, or like all like the volcanoes and stuff like that, more like upper mantle?
Yeah, I mean, to answer your question, unless the fluid comes to the surface carrying the remainder of some heat, that heat does not passively dissipate through the earth. That I'm aware of. Because it's a function of the pressure. When you remove the pressure, you remove the source of the heat.
I'm saying, like, does the heat like permeate through the layers and like radiate out?
I think not. I think not. Notice that the Earth's crust is a really fine layer on there. And I think it's kind of neat to think of this as like a really brittle crust on top of liquids. Like creme brulee. I like creme brulee. Like that little crystalline crust, and as soon as it breaks, there's all the liquid underneath. Like a scab, when you flex it, the juice comes out.
Yeah.
I have scabs. Those fish bite you sometimes. The whole thing about thumbing the fish, it's like low-class move, right? You feel the fish?
No.
You thumb the fish?
Yeah.
Did your thumb get all chingered?
Yeah, a little bit.
You just don't mind about it because you're a man, right?
Yeah.
Whatever. Coming in.
Okay.
So there's your crust. I want to remind you that you'll need to know the chemistry of these, the composition of these. Atmosphere, I think you know already because you've had that unit. Nitrogen, oxygen, silicon, carbon dioxide, you know that. The crust was a study goal that you'll need to know. Number 11, that one. And the numbers are a little different. The numbers do not necessarily exactly reflect your textbook. I'm not sure which one is more accurate. But you've got to recognize these numbers. The top 5 are like mandatory memorization. And this is just the crust. It's also mandatory that you memorize the composition of the whole Earth and of the core. Yeah? I think the definition of crust is the part which is solid.
So like all the oxygen you're talking about is like in the soil.
Where's all that oxygen, kids?
Those compounds.
Is there like air bubbles in rock? But that's not what we're talking about.
There's water.
It's not the water either. Well, maybe. I don't know.
There's one.
So then hydrogen actually is more.
No, even then hydrogen wouldn't be that much. Because hydrogen is not even top 10 for the Earth's volume.
But like
Oxidized chemicals.
H2O. I think that the majority of this O, they lied to you a little bit. You'll notice one thing that I didn't do. Look at how I wrote oxygen as an element. Look how they wrote oxygen as a gas. That's a confuser. When you see the O2, there's actually not 27% of the Earth's crust made of oxygen gas.
46%.
Whatever. It's oxygen compounds. They occur as oxides. Remember I told you that when you dig up a mine, the stuff that comes to the surface, it's going to oxidize. That's the oxygen in the rocks. It's not air bubbles. It's not the gas form. That's why it shouldn't say O2. It should say O is the element. the way I wrote it, for example. Now, notice this confusion. Why is it that 70 or 80 or 90% of the Earth's core is iron, but that's only 5% of the crust? And it's 46% of the crust is oxygen, but in the whole Earth it's only 30%. Why aren't these ratios the same? Why isn't the Earth uniform in its composition? But isn't there a whole lot of like mixing and stuff? Some are denser. There's this thing called gravity that separates the lighter and the heavier. And even more so, there's all this like geology and chemistry that keeps shuffling the deck. Now, it blows my mind that early in the history of the Earth, we were a big cloud of space dust, and as some of that stuff rammed into each other, we picked up enough mass to start pulling down more dust, and our solar system organized into those 8 planets, right there. And the part that I find most exciting is in that early life, as our planet started to cool down, it would be struck by meteors and turn to solid lava all over, like a big ball of juice. And then that juice would eventually condense into the crust on the outside, and then whammo, another meteor would stir the pot, so to speak, and we would be the planet of lava, like 4 or 5 times probably. We were a planet of lava. That's neat, right? One of those collisions spat off a little chip that got just far enough to balance the ratio of gravitational pulls and density and momentum, and now it orbits us. It's called the moon. The moon's a big piece of Earth. Yeah.
How does Saturn have to
The baby Jesus, obviously. Well, duh. I don't know, maybe more collisions? Maybe, less Dude, stop asking all these good questions! I don't know. Make me feel all stupid. It's because you're good looking. Doesn't give you the right one. Now, someday I will continue my science education and better understand this. To me, it's still slightly mysterious because I don't have quite enough chemistry to understand geology. But as you take that dried crust and you turn it into liquid, and these things happen, the layers keep getting shuffled. Now, I hope you understand that in the absence of any other forces, if you take the planet, you heat it up, and it melts into a ball of lava, and if you could somehow move the Earth and let it perfectly cool for once and for all, and just let it do its thing, and it cooled perfectly slowly with no other forces acting upon it, it would become a perfect jawbreaker of elements sorted by density. Does that make sense to everybody? With the heaviest, densest ones at the core, and the lightest, least dense ones on the outside. And we should have, in the absence of other forces, a perfectly layered cake of different elements. But because the planets are like spinning, and sunlight, and climate, and rain, and weather, and tectonics, they keep getting shuffled. So there's a few forces that have reliable shuffling effects, and you have to know them. And I have a slideshow, and you're expected to write them down. This is number 11. Remember, mineral compounds are dissolved. they're transported, and they're deposited. Anybody want to ask me about any of these terms, by the way? I have to assume you know all of them, because technically you should have learned this in 7th or 8th grade or something, but it's been a long time, and some of you were absent that day, you get hit in the head a lot, you smoke a lot of crack, so can I help you with any of these?
Melting?
Did you say what was all?
Dissolve, transport, settle, deposit. So can I help you with any of these words? Yep. Basically, it's not a single cycle, so there's a lot of back and forth in this. These are the full map of forces. So you should at least know those words. Those arrows are just attached to one word. There's no, like, it's not a sequence of events. Like your body has all these different things going on. They might have arrows, but it's not like your body's one cycle, right? Say.
This is like
Yeah? I guess because we only have like 30 seconds of class, I will not move on to that slideshow until tomorrow. But we're going to start with number 11 tomorrow.